Hello everyone, I am Kiran Devraj, working as Senior Technical Manager for India and Southeast Asia region. Today, I am going to talk about Hexagon manufacturing solution for mold industry. It's all about make it smarter. In this session, I'll be walking through some of the business challenges faced by mold industry and how those challenges are addressed by our end-to-end solution. Let me tell you how our customers are benefited with our solution with few live projects executed. The rapid development of modern 3D CAD systems have facilitated the evolution of product design and as a result, ever-increasing geometry complexity. Just think about the change in design from the conventional box-shaped vacuum cleaner to the modern Dyson. It is important to look at some key product design principles that will eliminate uncertainty and ensure manufacturability for your next project. So, definitely design aspects gonna drive quality, cost and time, and hence these turn out to be major challenges for any tool maker. You must ensure quality product is delivered at competitive price. Here I have a headlamp visor which is a plastic part. The story begins with customer sharing this physical part as an input for the project. So, toolmaker doesn't have anything apart from this physical part itself. This is where reverse engineering is important, and right from scanning to manufacturing, Hexagon solution ensures the business challenges are addressed. Let me take you through the workflow now. As you can see, the project inquiry is made with just physical parts shared. So, we begin with answering the inquiry and then through reverse engineering, physical part is digitized to get 3D model. Modified part as per design intent is taken forward for plastic injection mold tool design along by verifying plastic flow related manufacturing defects right at the design stage itself. Finally, part is produced with right manufacturing strategy with effective collaboration across departments throughout the project execution time. So, this workflow right from inquiry till dispatch ensure the first part is the right part at the right time. Let us see some of the different challenges faced by each department during the project execution and how manufacturing solution from Hexagon is going to helpful in order to overcome those challenges. At this initial stage, sales and inquiry handling team has their own challenges. Every project is an opportunity during an inquiry stage and it involves many stakeholders. It is difficult to update them with subsequent communications established with the customer as human errors are inevitable. Manual method of creating quotation and processing them into a sales order. Later, tracking all these becomes tedious with respect to individual project and difficult to maintain. At the same time, due to rising inquiries, prioritizing the technical tasks become a bottleneck for a project head. Let us see how work plan is going to be useful in addressing these challenges. At first, every inquiry is created as an opportunity by logging into work plan using your unique credentials. In this case, new inquiries received for plastic injection mold design of headlamp visor. Now this is important. Once opportunity is created, it can be converted into quotation in one click, followed by estimation of individual operations and material costs. You can also include other technical parameters affecting the project cost. You can see tasks and bill of material are listed. Now, sales manager can add margin in percentage along with relevant tax rate. Once the status is changed to send, quotation is ready. Either you can print this quotation or send PDF format through an email. This is time-saving option. Once the customer confirms the deal and release the purchase order, we can directly convert quotation into sales order in work plan. can also mention the deal price after negotiation along with the project deadline. Now in the sales order, let me update the PO number, that is purchase order, and the purchase order date. Let me also key in the required due date for this project. Now design task is created, along with the estimated hours to complete various design activities. Since customer has supplied the actual part with no drawings or CAD geometry, reverse engineering is the first step where scanning of the physical part is performed to create a 3D model. As you can see that I am entering reverse engineering, mold tool design and flow analysis as different design tasks along with estimated duration. Work plan stores all project related data and documents in single place, which is easy to find. Automation of RFQs, purchase order and sales order generation becomes easier. With the help of customized to-do list, all stakeholders of the project can manage and follow all their respective actions through work plan and customized email alarm notification. Project and sales department says, thanks to work plan. Now design department comes into picture. They have their own existing challenges, and on top of it, no CAD data available in this project. Converting the given physical part into a CAD geometry is a time consuming through conventional method, say calipers. Meanwhile, they must reduce the overall design cycle time during the mold design and have to fix all the manufacturing defects which are going to see during plastic injection molding process right at the design stage itself to avoid rework and additional cost. Let us see how Visi is helpful for design department to overcome these challenges. At first, the given physical part is scanned using hexagon absolute scanner, which is capable of scanning both matte and glossy surface finish with great accuracy. You can also see how dynamically cloud points are created in VisiRiver software. Configurable rest, effortless movement, essential security and absolute portability are some of the salient features of hexagon absolute arm. You can have multiple traverses on the part or tilt the arm at pivot to scan intricate details with great accuracy. This is how headlamp visor looks like in VisiRiver software as cloud points. So, once the cloud point data is collected, you are left with few unwanted points due to usage behavior. Now, let me filter those unwanted points using points filtering option in VisiRiver. You have multiple methods to choose accordingly. You can also retain original points collected as backup plan. Click preview. Here you got the filtered points. Let me use color filter options to delete those unwanted point data. Now, Let me convert this cloud point to mesh data and move to different layer. This is it. There are few areas which are left behind during the scanning of the physical part. Eventually, this creates a void in mesh data. Here comes automatic detection of gaps by highlighted color, the fill holes. Have a look. That's it. User will always have better control while editing the mesh to get refined and smoothing mesh data, which in turn helps in getting the right CAD geometry. As you can see that I'm adding few elements to complete the mesh data. Let me fill the remaining using fill gap option. This is the flexibility it offers to you. Now, let me refine the mesh. And now smoothen it. Let me follow default settings and click preview button. Perfect. Set on to the new layer with the different color. That's the original mesh and this is the refined and smoothened one. Adapting given mesh to plain cylinder or circle is time-saving option. As you can see how quickly it has regularized the feature. Let me repeat it on the other side as well. You can see that how easily features are regularized now. Now we are going to generate surface from this mesh data. Visireverse offers you various methods of creating surface geometry. I choose to extract surface from the curvature analysis method, in which the exact curvature mesh is converted into a surface geometry. Let me display the mesh curvature data with color mapping. And this is how colors are mapped. Now look how easily and accurately surfaces are created onto map curvature mesh data. I would say quality of the surface depends on the mesh quality. So now this mesh data is going to be converted into a surface now. So let me click on preview, sit back and relax. Surfaces are going to be created for you. Look at these surfaces created so far. Brilliant. Let me save it onto new layer and name it as surfaces. This is important. Visireverse not only generates surfaces. By using regular CAD functions, you can easily create solid geometry also. That's how VisiReverse is unique in its own style against using generic software. Let me show you the CAD solid geometry through dynamic section view. There you go. Right from cloud points to filtered points and then to mesh data, which is further refined and smoothened. Later, extract surfaces from curvature analysis method, and finally 3D solid geometry. Now let us see how VisiMold is used to build mold tool for this plastic part. Visi takes you through series of operations close to practicality. As a first step, draft angle is visualized, and this will also display the faces to be drafted. Let me assign the material and shrinkage properties as per the material data. Visi has very rich material database. Now defining the shrinkage point and then apply. Now let us create split line and parting surface using dynamic and automatic option. Provided the right draft angles and pulling direction, Visi is very powerful in splitting the complex geometry. Let me use split plane and convert into a shaded mode. Let me select the desired method of surface creation. You can see how shut-off surfaces are created automatically. Visi offers more flexibility and control for the user while creating parting surfaces. So let me show you how this is done. Due to flexible selection methods, you can create parting surfaces with less number of clicks and picks. That's how surfaces are created. Let me extend onto the other side now. And let me confirm this option. Now I'm going to unite it to create a single parting surface. Look at the ease of creating surface geometry as parting surfaces, especially during complex part. You can even import sheets from other CAD system to define it as a parting surface in Visi. That's the flexibility it offers to you. Let me convert into a face set and then show you the splitting. Core and cavity inserts for the given plastic part is ready in less time. Using direct modeling functionalities, inserts are created with less time. Now let us build mold tool for these inserts. Using standard mold tools from Hasco, you can create the mold tool very quickly and customize plate sizes accordingly with ease. You can either delete the existing plates and add your own custom plates created and save it as a template for further reuse. Now let me delete some of the available plates which are not essential and add a custom plate into the tool build. You can see that I'm going to add another one. Let me delete this. Add the existing plate. So in this way we are customizing the given mold tool base. In one click, standard elements are added along with tool build. Now let me configure standard elements by removing some of the parts which are not essential by ticking or unticking these options. Let me subtract the entire assembly level and let me show you the tool design now. Let me open this. This is how easily we have built the mold tool. Now let me show you how to add side cores, lifters and some more elements from standard supplier catalogs. Visi has a wide range of standard elements as per global suppliers. Misumi, Musburger, Futaba, DIN, DME, Strat, etc. In this case, let me configure the dimensions of site core elements used. I hope you are seeing that how quickly we have added the site core elements in just few clicks and picks. All you must select the start plate, end plate and configure the size and use it. Now you are seeing how the lifter is added by selecting the top plate, end plate and configuring the dimensions. Let me show you the wireframe mode for easy visualization. After adding a lifter here, let me mirror it onto the other side. Let me add few more standard elements. Visi offers you a complete flexibility in mix matching different elements from various suppliers as per your design intent. Now let us define runner gates and cooling channels along with standard paths in Visi mode. Dedicated commands for defining these features are very much helpful in reducing the design cycle time. You see how quickly we have defined and added runner gate system to the part. Now let me add a cooling channel along with standard fittings. Let me solidify these elements to reflect cooling channels. Imagine we are creating these standard elements manually or downloading from different platform, which is always vulnerable to data security or time-consuming process. That's how cooling channels along with standard fittings are defined. Let me subtract the entire assembly to reflect recently added standard elements. Once the mold tool design is completed, it has become mandate to check for manufacturing defects like air traps, short shots, sink marks, well lines, warpage, etc. before injection molding process. Visi flow is the need of an hour. With easy and simplistic user interface, even non-CAE analyst or engineer can learn Visi flow quickly. It has very short learning curve. Even regular tool design engineer can use this software at ease. All you must define the boundary conditions like material, injection point, mesh attributes, etc. Visi flow has thousands of material database as per industry standards, which is rarely available as open source. Once these boundary conditions are defined properly, sit back and relax. Powerful Visi flow solver computes the mathematical model and generates the results for you. Let me show you filling analysis results now. It is quite easy to create a comprehensive report in Visi flow. You can capture various plots as an image file, and also a video file can be created having all these animations of various parameters for easy interpretation and also for a better communication with your customer. Some of the plots like pressure distribution, knowing temperature plots, and flow pattern are important to derive or interpret the mold design and suspect any manufacturing defects right at the design stage itself. You can find relevant issues during the filling cycle, namely well lines, air traps, etc. From this stage, you can interpret the result accordingly. Further, you can proceed with packing and shape analysis to find sink marks, warpage, etc. As I said, it also suggests the quality of the part from the mold. You can see here, I must improve my design to bring down temperature and stress parameters within the acceptable limit. Now imagine you must share this CAD file with your manager who don't even have CAD license to view it. This is where Work Explorer comes into picture. Let me tell you how. Using Work Explorer, your manager can open any CAD file and make his comments or annotations on design changes and share it back with subordinates. As an example, manager is conveying to use runner gate design from previously executed similar project and rerun the analysis for temperature and shear stress effect to be corrected. Let me show you how to create few labels for individual parts. This is easy. Furthermore, you can visualize the entire assembly file with all the individual part information on the fly. When a face is selected, you can see relevant information like surface area, dimensions, draft angle, surface type, etc. If you select solid part, volume, weight, center of gravity and other material properties are displayed. You can check for the dimensions of any part by selecting an edge, point, face, solid, surfaces, etc. or between any two entities. And look at this, how easily you can section the assembly and create sectional curves along with the active measurement tool and the dynamic section view. You can use the simple triad and move around or along the axis. Flip the view and measure. That's it. You can save into neutral file formats like STP, IGS, DXF, etc. So finally, nothing is completed without documentation, and Visi Drawing automates this process by creating part drawings on individual sheets. Yes, you heard it right. You can take sectional views, detailing, dimensions, geometric tolerances, and dimensions, whatnot. You can generate bill of material and export it to a plan for further action. You know what? Even you can export your CAD data to view by your customer who don't even use Work Explorer. Yes, you heard it right. In addition, you can protect your document with password. That's the uniqueness of Work Explorer. You can also make this file accessible to all project members who can view the file without installing Work Explorer on their computer or a laptop. That's how effective collaboration is possible using Work Explorer. With the help of VisiReverse and Absolute Arm, physical part is scanned and converted into 3D CAD model. Using VisiMold's salient features like standard elements and tools library with the ease of creating core cavity inserts, overall mold design cycle time has reduced. Early detection of manufacturing defects such as air traps, short shots, well lines, etc. using VisiFlow has drastically reduced mold rework, thus saving additional mold cost and time. Hence, the design team always say, Visi, it's easy. So now project is moved to manufacturing team. Let us see their challenges while managing materials required for production. Materials management is an important aspect as it involves cost and delivery lead time. For every project, there are various raw materials required as well as the standard elements, and it is very much important to get the progress of raw materials ordered and maintaining the inventory level to have the minimum inventory cost. After receiving the final bill of materials and before proceeding with material procurement activity, it is better to see the entire CAD assembly once for better visualization. Any non-CAD engineer can do it by themselves without troubling design engineers for the same, thanks to Work Explorer. With Work Explorer, you can also get the bounding box for dimension to ensure the size of raw materials to be ordered. Store in charge will cross-check the available stock quantity for the standard elements required for the project, and he will reserve it if he finds the sufficient stock material available. For raw materials, very quickly the purchase order can be created and it is possible to select the supplier of your choice. At purchase order screen, the details of the raw materials will be cross-checked and finally, the status of the purchase order will be changed as ordered. After that, the purchase order can be printed to share with the supplier. When the ordered material arrives at the company premises, then the store in charge will make the purchase order receipt for the same and he will confirm the same through dashboard. After that, he can print the goods receipt note for the material received for ease of documentation. With work plan, it becomes very easy to manage the materials required for the various projects. You can reserve stocks for standard elements, purchase order and goods receipt notes creation is just a click away. Material handling team is very happy with work plan in place. Now let us move to the next stage, that is planning and scheduling, which is an important aspect in case of die and mold manufacturing, as there are various projects running at shop floor. If you are a plant manager looking after the project from manufacturing perspective, it is very much important for you to know the progress of every single project along with its deliverables and the time including the loading of individual machines. You hardly get time to run from pillar to post, and hence working with limited resources becomes challenging. In addition, tracking estimated versus actual time spent through conventional method is always a mislead. To do the detailed and accurate process planning for the project, it is important to study the part CAD model. Work Explorer helps a lot to visualize the CAD model much better way to make crucial notes. You can even assign the material texture to the part CAD model as per your requirement. Planning engineer will do the process planning for every sub-assembly of the project. A top plate, bottom plate, core plate, cavity plate, etc. This process planning will include the definition of the operations along with their planned duration and defining the links between them as per the actual manufacturing process flow. Once the planning part is done, projects can be added into the scheduler and the priority of the project can be changed as per the requirement. Automatic rescheduling of the task will give the result of a scheduled start date and end date for every project along with the load on every resources. The resource loading will tell us the task scheduled on different dates on different machines, and this information can be provided to the shop floor for their references. With work plan, planning and scheduling of the projects has become an easy task, and it gives a clear visibility about the time plan for every project as well as loading of all the machines. This is where you reap maximum capacity utilization, achieve real-time deadlines, and with transparency by sharing actual reports with stakeholders. Now we move on to the CAM programming. CAM programming being the heart of manufacturing, their challenges are very crucial and these must be addressed with no bargain. They always be under pressure to achieve tight delivery time, ensuring less machining time with increased cutting tool life. But this remains a challenge for every then and now. Let us see how to tackle this. At first, task is initiated by creating the work zone in Work NC, which is attached to the respective machining tasks in the workflow. I mean work plan. WorkNC being premier and automatic CAM software for die mold and toolroom business, it has many salient features to offer for the community. It has a dynamic stock management which allows you to define raw material with multiple ways. This option is helpful in defining raw material to generate roughing and rest roughing tool path. You know what? The stock model is further usable for simulation purpose. In WorkNC, all toolpath parameters are visible and displayed through a single window, making it easy to achieve toolpath strategies for all types. You can see that tool library and holder library are available in toolpath parameter form. Generation of holder-based roughing program is very much powerful in WorkNC as you can detect holder collision during calculation. The advantage of this option is you can achieve the maximum machining depth by using minimum tool length. You can easily switch between the toolpath strategies at any time by keeping the same tool and the cutting parameters. By using progressive simulation display, you can check the actual machine simulation by defining the stock model. It displays the stock-based simulation. You can also check a wireframe simulation for the toolpath. Before releasing the toolpath into the shop floor, you can check this material cutting activity inside the software. Work&See is very strong in roughing strategies, as our patented waveform works for all cutters irrespective of cutter profiles. You can also check machine simulation inside the software with the help of virtual machine model. Realistic machine simulation is possible as you can check all machine axis travels during the machine simulation. Machine kinematics along X, Y axis travels and along B and C axis travels will help to find whether the machine is going out of limit or performing the cutting activity within the limits. This is very interesting. Work&See has Order 5 option. Using this option, you can convert any 3-axis toolpath into 3 plus 2 axis program or a continuous 5-axis toolpath program. With this option, you can achieve the maximum machine depth with minimum tool holdout length. Look at this inbuilt machine collision detection option. Which will display you the results like linear and rotational limits are okay or not, along with displaying the results of collision between part and the machine, between holder cutter and the part itself. Work&See has dedicated 2D module to machine 2D features like drilling, tapping and reaming operations. Once all toolpaths are completed, you can generate NC code by selecting the post processor from the library. After generating NC file, you can generate HTML document where all the cutting parameters and the cycle time are displayed. Once this activity is completed, you can validate the G codes and M codes by taking this NC file into NC Simule. I will talk about it a bit later. Meanwhile, under the machining task in work plan, Work&See work zone can be seen along with the process sheet documentation. Here, toolpath time from work zone can be imported as forecast time for the machining task. CAM programmers can log into the Quick Access tool and select the option Time Entry. This will help them to book the real hours spent on the task on different days. Very quickly, they can select the task and book the real-time entry spent on it. As the task is completed, status can be changed as terminated. Work&See has accelerated delivery time with fast calculation and efficient programming. It also minimized the manufacturing cost through holder-based programming and collision check with improved productivity. Now it's time to validate and optimize the NC code using NC Simule. It forms a bridge between engineering and production department. It will simulate NC code which are generated after post-processing, because in CAM system, after generating toolpaths, you launch simulation and then generate NC code which remains unchanged. NC Simule combines the digital advancement of Industry 4.0 When you maintain the quality and manufacture the right part, which is machined correctly the first time, and NC Simule works with any CAM software you have it. Once you have the project ready in WorkNC, you can launch NC Simule WorkNC interface from Utility drop-down menu. The moment you launch, another window will be opened which has all the information about models and fixtures used along with machining process data. You can pick the machine upon which codes has to be validated. Let me define program origins for this newly selected machine. The project created will directly open inside NC Simule, which is now ready to be validated. Interface is very soothing as you can toggle between machine, part or both the views. You can conveniently customize the interface by hiding those icons which are not necessary. With few clicks and picks, all relevant information like parts, stock, tools, machine used with tool assemblies and the programs generated with native CAM software are available in NC Simule. The moment you load CAM program in NC Simule project, it will start decoding it and find out errors automatically, which your real machine controller is not going to accept it. And this will ensure the given error must be iterated manually on the machine. On the right hand side, I shall navigate through program lines to understand the code's behavior on the real machine. Meanwhile, all these errors are identified and rectified, which will then processed for simulation. Before launching simulation, parameters must be set like collisions, tolerances, machine clearance, rough clearance, holder clearance, brakes, simulation mode, gauged material, etc. You can also set nearness clearance allowed over here. These parameters defined will be used while computing simulation. Now let me run the simulation. As you can see, it gives me clear-cut idea about how material removal process will be in real-time scenario. You can also check collisions if any. Errors like rapid motion entering the part or spindle status, cooling status, etc. are known well in advance to reality. If any collision is detected, then you have full control to modify before sending it to the real machine. In NC Simule, it will show you exactly how the metal is removed on your real machine. It will show you the tool path with its retract rules as well. When it is moving from one cutting region to another cutting region, and here you can see the simulation in this step. Now, next step is part validation. For that, we go in comparison. Here your design model is compared with the machine model and you can see the result in colored plot available here. You can see the rough material, gauged material, even the surplus material, and then we can change the deviation of the tolerances and you can see that effect on your simulated part here. We have a tolerance chart which can be changed dynamically and you can see this updates your colored graph directly onto your simulated part. At any time using probe on the computed part by just going with random click, it will show you whether it is having excess material or your tool has gauged or any collision detected, etc. Furthermore, you can have 3D section plane for your component to inspect internal features like drills, tab sizes, etc. 3D dynamic section is so flexible, It helps to visualize by tweaking either linear or angular triad. Furthermore, you can measure any geometrical entity of the model like thickness, hole distance, height, datum references, etc. You can even measure fixtures, tool, parts, etc. used in this project. Now, let me show you tool length optimization. This will give you the optimum length of the tools to be used for this project, so that it optimizes the tool life along with the good surface finish. You can see the list of optimum lengths as a result. NCDoc will create a technical sheet which is customizable as per user's requirement. Like operator name, company name, different languages, etc. This sheet can be a one-pager or have a detailed process sheet with machine information, offset information, tool list, etc. Let me show you the preview of NCDoc. This is how it looks like. Part information, project operation sequence with the tools used, tooling information, assembly information, and many more. You can also export this sheet as Excel, Word, PDF format, and many other file formats for easy and effective collaboration and documentation. After ensuring the data is error and collision free, you can optimize the program straight from your CAM software in NCSimule by using OptiTool. Here, you can save the cycle time by 5 to 10% depending upon the material and tools used in the project. You can set tool sequences, NC tapes, and cutting analysis prior to optimization. For your information, there are two ways for optimization. One is air cut optimization and another one is in-feed optimization. In this project, we were able to save 9% of cycle time, and you will get the complete analysis or the time saving for each tool used in the project, and finally, you can rewrite the program in original syntax, and these programs are checked and 100% error and collision free, which you can safely send it onto your real machine in your shop floor. Once the validation is done at shop floor, machine operators have to log in to the touchscreen application using their credentials. They can select the task on which they are going to work along with the machine resource. Once the task is selected on the machine, from that point onwards, the real hours will be booked automatically on the task selected. When the current task is completed, operator must select another task on the same machine. In case the previously selected task is completed, it can be declared as finished. So, no more long shop floor proveouts, avoided iterations on machine controller, and reduced downtime of machines. You have also seen how only foolproof programs are transferred to the machine and ensured machines are kept running unattended. At the same time, your colleagues are tension-free on shop floor. Now the project is at its last stage, that is dispatch. You must ensure dispatch should be without any quality-related issues, avoid last-moment approvals which further delays delivery time, and no manual work. Strictly no manual work. While dispatching the final product to the customer, some value addition service is always good and helpful. So, instead of troubling design engineer for the same, any non-CAD engineer can create some product scenes and add some text or annotation if needed. Multiple scenes along with the appropriate information can be created as per the requirement. After successful creation of the scenes, very quickly PDF documented can be created for the selected scenes. Now all the tasks of the project are completed and it is ready to deliver to the customer. Source in charge can create the delivery note for the project. The delivery note can be printed very quickly to submit it to the customer. Finally, invoice for the project is created. After cross-checking the invoice amount, status of the invoice can be changed as sent, and very quickly invoice can be printed to share it with the customer once again. With the help of work plan, your dispatch and delivery process is automated and smoothened. Remember, this is always scalable and flexible, thereby reclaiming itself as powerful manufacturing operations management tool. So that's how we have utilized Hexagon production software solution right from project inquiry till dispatch. And these are all the modules what we have used so far. It includes Hexagon portable scanner and VisiReverse for reverse engineering, VisiMold for designing mold tool, VisiFlow for plastic injection mold simulation, Work and See or even VisiCamp for toolpath generation, NCSimule for verification and optimization of HC codes, Work Plan for complete manufacturing operation management, and we have collaborated using Work Explorer across departments and all the project stakeholders. Few of the sample projects executed by our customer. This is automotive instrument panel and some statistics of the project for your reference. It has about 5,000 plus solids, over 1200 screws, having 600 plus cooling channels with 6 part changes, working with 486 hours design time with 3 concurrent designers. I have a customer success story to share with you. It is Georges Bernard. They are into manufacturers of mold tools for automotive, domestic appliances and construction industries. They design and manufacture tools for plastic part injection, composite and die casting. They have shop floor at Portugal and mold parts manufacturing setup at Slovakia, China and Portugal. Their major challenges are to optimize IT resources and solution, digitalize conventional designs and documents, stay competitive in terms of price and quality of the product, reduce unwanted time consumption in non-productive tasks, thereby allowing some room to be ready for Industry 4.0. Association with Hexagon production software for more than 17 years, and with these solutions from us, that is Visi, Work and See, Work Plan and Work Explore, they have overcome their challenges. And in addition, they have optimized IT resources, stay ahead of competition, access data across different branches, cut down cycle time and improve overall manufacturing productivity with quality product delivered. Mr. Gilles Bernard, the CEO of the company, says like this: after using the system for 2 years, we achieved a 35% reduction in time spent on non-productive CAD tasks. This is something remarkable. So to summarize, end-to-end solution from concept to reality using Hexagon products helped in optimizing product design, manufacturing cost and cycle time, increased overall productivity with effective collaboration across departments. Finally, your customers are happy, so we are happy too. Thank you so much.